All right. Now let's consider the last but one question. The graph of a function is obtained from the graph of y equals f of x by first stretching vertically by a factor of 3. So I have A saying it's obtained from the graph of, we have graph of y is equal to f of x. They are saying by first stretching vertically by a factor of 3. Okay, so we have 3, then f of x. This is what? A vertical what? Stretch. If this is your first time, kindly visit my previous lecture slides on transformation of functions. I've explained this into details. So by first stretching vertically by a factor of 3, and then from here, and then shifting upwards by a unit of 2 or by 2 units. So shifting upwards this way for r plus what? Plus 2. So the question is, give a formula for the function in terms of f. So this is the answer, all right? So B, the graph of a function is obtained from the graph of y is equal to f of x, right? We still have our y is equal to f of x. By first shifting upwards by 2, is that also? So by first shifting upwards this way, shifting upwards by 2, okay? And then stretching vertically by a factor of 3. So what I'll do is, I'll enclose this in parentheses, stretching by a factor of 3, this way. Please take note of this. We first focused on this and we stretched, like it was vertically stretched by a factor of 3. So 3 will affect whatever is here, which is different from this, all right? Then C, okay, then give a formula. So this is the formula. C, are the results of part A and B the same? So let's do comparison. This is A. A is y equals 3, then f of x plus 2. Then B, we have 3, then we have f of x plus 2. Are they the same? Not at all. Because this is the same as 3 f of x plus 6. You see, and they are very different. Right. Okay, so are the results of parts A and B the same? If not, how are they related? Okay, so this and that, when you graph them, you will have the same shape, all right? So how are they related? So this is how they are related. So this, so this function, okay, is the same as this by a unit of 4 vertically upwards. Okay, so you can see we have 3f of x here, 3f of x here, you have 6 and you have 2 here. So this one is just this, shifted vertically upwards by 4 units. So it's like 6 minus 2, you have 4. So you just picture it that way. So that's it. So let's consider the second question. Write formulas for the functions, okay? So you have your xy plane, line 1, line 2, line 3, or line 1, line 2, line 3. However you do it is up to you, okay? So you have this line with coordinate, where the points. You have this line with a point. You have this line to it, a point. Okay. So how do you go about it? So let me call this line 1. Let me call this line 2. Let's call this line what? Line 3. Okay. So for L1, okay. So for line 1, these are the coordinates. 1, they have 6.5. They have another point, this 3. They have 5.5. Okay. So if this is x1, y1, this is x2, y2. So I'll just find the gradient. Okay. So I have gradient equals change in y over change in x. So we have y2 minus y1 over x2 minus x1. So I'll have this y2 is here is what 5.5 minus y1. Y1 is what 6.5 over x2. We have 3 minus 1. So m is equal to half. Then we can decide to take any of the points. Okay, so I'll take the first one. So taking the first point, 1,6.5. We know that y equals mx plus c. Okay, we are using the straight line equation. Okay, this is not a parabolic curve, hyperbolic curve. No, straight line. It's a straight line graph. So we have it this way. So if I take, if this is my x, this is my x, and this is my y. So I have my y is what 6.5 is equal to, the gradient is what, half, 1 over 2. Then what is my x? My x is what? Is 1. Then plus c. Okay. So I have 6.5 is equal to half plus c. So c is equal to, so by the help of the calculator, we are getting 6.5 minus 1 over 2, giving us what? 6. Okay, so we have this, half y is equal to, my gradient is what? Is half from here. Half, because I maintain y over here, I also maintain what? X over here. And what is my intercept on my, this, the intercept here is what? The c, which is my 6. Okay, this way. Let's consider the second one. So we are done with this. Let's consider L2. Okay, for L2, these are the points, this and that. Okay, so we have 3, 2, then we have 5, 2. So this is x1, y1, x2, y2. So the gradient, so this is gradient 1, okay, so this is gradient 2 is equal to y2 minus y1 over x2 minus x1. So we have y2 is 2 minus y1 is what? 2 over x2. x2 is what? 5 minus x1 is what? Is 3. So everything goes to what? Goes to 0. Alright, so you can decide to pick this point or this point, okay? So I'm taking the first one, 3, 2. Know that y is equal to mx plus c. Is that also? So here I have my x here, I have my y here. So my y here, I have 2 is equal to, gradient is 0 times x, x is what? Is 3 plus c. Alright, so we have 2 is equal to 0 plus what? C. So c is equal to what? Is equal to 2. So therefore, we know that y is equal to my gradient, which is what? It's supposed to be this, mx plus what? C. So y is equal to, because the gradient is 0, so we have 0 times x plus c, which is 2. So y is equal to what? Is equal to 2, this way. And the third one is, so for L3, this L3, this and that, okay? So I have the point 5, 7, and 7, 3. So x1, y1, x2, y2. So gradient 3 is equal to y2 minus y1 over x2 minus x1. So I have m3 is equal to y2. So I have 3 minus 7. 3 minus 7 over 7 minus 5. So 7 minus 5. So I'll get m3 is equal to negative 4 over 2. So I have m3 to be equal to negative what? Negative 2. So I can decide to take this point or this point. So I'll take the first one. So I have 5, then 7. I know that y is equal to what? Mx plus c. So this is my x and this is my y. So I have 7 is equal to, what's the gradient? The gradient is what? Negative 2. Then what is my x? My x is 5 plus c. So I have 7 is equal to negative 10 plus c. So I have 7 plus 10 is equal to c. So therefore c is equal to what? 17. So we know that y is equal to mx plus c. So we have y, I'll maintain my y here. But I know my gradient to be what? Gradient here was negative 2. So I have negative 2, I maintain y here, so I also maintain my x over here. Then plus the constant, which is what? 17. So whenever you are being given graphs like this is why it's just a piecewise function, okay? So we'll talk about piecewise functions in the future. So you just have to find for gradient for each line, then you proceed from there. Alright. So I'll say let y, which is equal to f of x, denotes my function, okay? So this is how piecewise function, like the graph for piecewise function, this is how it's written. So we'll just open a large curly bracket, then we try to, whatever we solve for will be here, okay, in order. So this is just the representation of a piecewise function. So let y equal to f of x, which is equal to, then I open my curly bracket. Then I started with this, right? So I'll write it this way. So I have 1 over 2x plus 6. So this is the first one, right? And this is my second one in order this way. So I have 2. Then the third one, this is my third one, okay? I have what? Negative 2x plus 7, okay, plus 17. So here we have conditions. Okay. So for here, we don't know the starting point of this line. We don't know the starting point, but we know the end point. So if this is the line at the end point, if you trace this over here on the x-axis, you realize that it's what? It's here. It's pointing to what? To 3. Is that also good? So the inequality, okay, so the interval will be what? Because here is shaded, that means the end point is inclusive. All right. So we have, and it's pointing towards what? It's on 3. So I have x is less than or equal to what? 3. So this will be the interval. So you get it that way here. So this because 3 is what? Is inclusive. Okay. Okay. So that would be the condition for the first one. So given that for x, so this one will be for x less than or equal to what? Equal to 3. Let's move on to the second one. Here. For the second one, realize that this is between 4 and 6, right? So if I trace this point, this place becomes what? 5. Is that also? Then when I also trace this point, it's also on the 3. So it's between, so here is the range. Is that also? So the interval becomes what? We have 3, but this side is not shaded, so it's not inclusive. Okay, so to do that, you just write 3 is less than x. Okay, and note this one is also what? This is inclusive. Less than or equal to what? 5. This way. So that is the range. This is exclusive. This is what? Inclusive for the L2. So I'll have to add the condition there. So you have 2, 4, 3 less than x less than or equal to 5. And the last one, step by step. Yeah. This is L3. Let's focus on L3 here. So I want to trace this to touch the x-axis. But because this is not drawn to scale, I would use the coordinates here. Okay. So my x here is equal to 5 tells me that is, if I'm supposed to do the trace, if I trace the point, it will fall on what? On 5. Okay. Because it's not drawn to scale, when I try doing this, it will fall over here. Do you get that? Which is not really appropriate. So it falls on what? On 5 because of this. So when you come here to see for this, see when I trace the point, it's on 3. It's on 3 because the coordinate here was given 3 for x. So here too, for x, you see it's 5. So you can just use the coordinate to do your positions, okay, with respect to the x-axis. You get that way, all right. So here, x is equal to 5. Is that also? So 5 here. So let's say 5. But we don't know the terminus point, all right? So we can just say, so the condition here will be x. So we have x, and it's not also shaded. This place is not shaded. So we have x greater than what? Greater than 5. And this is the condition. Greater than 5. So I have it this way. For x greater than 5. Viewers, this is the end of the lesson. So far as Tindanious YouTube channel is concerned, we are going to learn a lot. Bye.